Here we have a look at a periodic table, and there is a lot of useful information on this table, and we want to be able to utilize that information to solve a number of kind of chemistry problems that we're going to have this semester. So as we talk about the numbers that we have on the periodic table, the first thing that I want you to notice is that as we move across the rows on the periodic table, there's a number located in the top of each box, and that increases as we move across. So notice that every single box on this table has a different number in the top. That number is going to be a very unique property of elements, and it really is their defining characteristic. So we're going to take a closer look at the periodic table and start off by talking about that number that's located in the top of the box. So as we look at this close-up example of the periodic table, the number that I'm talking about is this number located right here. And this number is what we refer to as the atomic number. As I mentioned, this is going to be a unique number for each element. And specifically what this number tells us is it tells us the number of protons for that element. And so every single element is going to have atoms that have different numbers of protons in them. And when you look at an atom, if you were to locate an atom and be able to tell how many protons it had, you would know exactly what element you're looking at based on this number alone. So when we write that atomic number, if we were writing a symbol here, we would write the atomic symbol and we would include the number as a subscript on the left-hand side. Sometimes this atomic number is written next to the symbol, sometimes it's not. And that's because that number could very easily be looked up if we had a periodic table available to us. So we definitely want to know that if we know the atomic number, we already know exactly how many protons an element has. Now, another useful piece of information that we have on the periodic table is the number that's located in the bottom of the box. And the number that's located in the bottom of the box is going to be what we call the atomic mass. The atomic mass is an average mass, and so it's an average mass for that particular element. Recall that we've already talked about the particles that make up an atom, and when we talk about the mass, there's really two types of particles that contribute to that primarily, and that's going to be the protons and the neutrons. So when we get this average mass, that is pretty much what we're talking about. We can talk a little bit more specifically about the mass of an individual atom, and that's what's going to be called the mass number. And we've discussed the mass number in an earlier video. But the mass number, if we were to write that next to the element symbol, we would write that up here at the top. So if I put it on hydrogen and I just look at an example, we could have a hydrogen atom that has a mass number of 2. Okay, so again, we want to emphasize that this number here, that's the mass number. And mass number is going to be the mass of one specific atom of an element. And then down here at the bottom, this is going to be the atomic number. Here I have a carbon atom. Carbon always has an atomic number of 6. So I'm going to go ahead and write that on there as a subscript. And in this example, I've got a carbon atom that has a mass number of 13. And my question here is, how many protons does this carbon atom have? And I also want to know how many neutrons it has. The easier of the two questions to solve is really the first one, because remember that the number of protons is a unique characteristic for an element. So for carbon, that's always going to be whatever the atomic number is. And in this case, that atomic number is 6. So the number of protons is equal to 6. And now I'm going to move on to figuring out the number of neutrons. To get the number of neutrons, I would definitely need to look at that mass number. So if I look up here at my mass number, remember that the mass number is going to be equal to the number of protons plus the number of neutrons. So since I know my mass number is 13, and I've already solved and figured out that my number of protons is 6, this is really the setup to answer this question. So all I'm going to do here is I'm going to solve for n, And as you can see, N is going to be equal to 7. So I know that my number of neutrons is going to be 7. So I've already figured out the number of protons and neutrons that I have. Now the other particle that we haven't talked about here is going to be the electrons. And if we want to find the number of electrons, to figure that out, we need to know the charge. So if I'm looking for the number of electrons, the charge is the important part. And the charge is going to be located right here. So this is where we would find the charge of an atom. And if you'll recall, we have two different charged particles. The charged particles, this is going to come from the protons, which have positive charges. And then it's also going to come from the electrons, which have negative charges. Now, if you don't see an actual number or charge written there next to the atomic symbol, that means that we have a charge of 0. So in this case, that's exactly what I have. I don't have a +1 or a -2 or anything like that written. So what it really means is that we have a little 0 located here. Well, if we have a 0 there, we know that the number of protons and electrons are going to be equal to each other. So that's the easy scenario. And in that case, since we know the number of protons is 6, we know that the number of electrons is also going to be 6, because that would balance out the charges and give us that overall neutral or 0 charge. Now that's not always going to be the case. So let's look at an example where we have something that's not neutral. So if we look at a slightly different example, here I've got oxygen, and I'm going to have a -2 up here for my charge. I'm also going to put the atomic number of oxygen on here so that we can see it. And I'm going to put the mass number here as well. So to start us off, to figure out the number of protons, hopefully we can see that that is going to be 8, because again, that's whatever the atomic number happens to be. For the number of neutrons, we're going to use that mass number to calculate that. And our mass number is 16, and we know that that's going to be equal to the protons plus the neutrons. And since I know my protons are 8, I can solve for N. So N is also going to be 8. And then that brings us to our number of electrons. So to calculate the number of electrons, I'm going to utilize the information here in the charge. So when I see this -2, that means that my charge is going to be equal to the number of protons minus the number of electrons. And the reason I have the minus there is because the electrons have that negative charge. So another way to look at this is we could say it's going to be the positive protons plus the negative electrons. So that would just be another way to write it. So as this comes out, we have a -2 charge. We're going to have that equal to our number of protons, which is 8, minus the number of electrons, which is what we don't know. So if we solve this, to solve this for E, we would subtract our 8 off both sides. So we come out having -10 is going to be equal to -E. And of course, we can cross off both of the negative signs, and that leaves us with 10 electrons up here. If we wanted to double check this, remember that your protons are always going to be positive. So we have a charge of +8 contributed by our 8 protons, and we have a charge of -10 contributed by our electrons. And when you put those two together, you would want to make sure that they do come out to that overall charge that we have written right here next to the oxygen. So if you are provided with the information that you have right here, so an atomic symbol, its mass number, and its charge, you want to be able to calculate the number of protons, neutrons, and electrons.